Now, with LeChatelier's principle, people tend to struggle with this, but I think once you get the gist of it, it makes sense. Now, what LeChatelier's principle is, came from a French chemist, Henri LeChatelier, and his principle was that if a stress is applied to a system that is in dynamic equilibrium, the system changes and relieves that stress. So if I have an equation, it is at chemical equilibrium, it's a reversible reaction, and I do something to it, LeChatelier says that that system will adjust to make up for that stress. So, what he said was that certain things are the stressors, one of which is concentration. So, if I add a reactant, or I subtract a reactant, if I add a product, or I subtract a product, I am making a stress on that particular part of the equation. So, if I change the concentration, which is just basically adding more of it. Okay? So if I look at this, it says adding a reactant will push it towards the product side. Removing a reactant will pull it towards the reactant side. The same principle applies with the product. So, basically, if I'm looking at this, okay, if I'm looking at this, and I say, I got my equation. Here is my reactants. Okay, it doesn't matter what they are. Here's my products. Now, I think of this as putting in a fulcrum here. I've got a teeter-totter. If I add, on my teeter-totter, if I add reactants here, what's going to happen in the teeter-totter? That side's going to tilt down, isn't it? It's going to be heavier. So what way will the equation adjust? It's going to go that way and make more products. Okay? So, if I add more reactants, the equation adjusts by going that way and forming more products. Now, what happens to my teeter-totter if I take reactants out? If I remove them? Well, I'm going to have less weight on my reactant side, right? So my reactant side of my teeter-totter will go up. So then the equation will adjust by making more reactants. Now, this is used commonly, folks, because let's say we have a product that we really, really want. Okay? We've got a product that's really, really valuable for us. Once it makes that product, I pull it out. I pull it out. So what happens? What's the equation do then? If I pull out a product, what's my teeter-totter going to happen? Okay? It's going to make this side go up, right? So how does LeChatelier adjust it? It goes back to the product side. So it'll actually make more products. Now, change in temperature. It's the same thing. Okay? Increasing the temperature causes the equilibrium to shift in the direction that absorbs heat. So, if I look at this particular equation, it's a reversible reaction. So it's going both ways. If I'm looking at the forward reaction, okay, it's exothermic because heat is given off, right? If I look back at the reverse reaction going this way, it's endothermic because heat is taken in. So, once again, my teeter-totter here. Here's my fulcrum, right there. if I increase temperature is really doing what? Adding heat, correct? So if I add heat, what side of my teeter-totter is going to go down? This side, right? So if I add heat, that side of my teeter-totter goes down, so it shifts to make more of the reactants. Now, what if I take away heat? I decrease the temperature. If I decrease the temperature, this side of my teeter-totter here is going to go up, isn't it? Because it's not going to be as much. So then it's going to adjust, the equation's going to adjust to make more of those products until it evens out back into equilibrium. So LeChatelier's second is heat. His third is changes in pressure. And this one is the toughest one in my opinion. This one is the toughest one in my opinion because we have to do a little bit of thinking here. With pressure, a change in pressure will only affect the equilibrium on unequal numbers of moles of gaseous reactants and products. So, number one, everything has to be gases for pressure to affect it. All right? Number two, there has to be an unequal number of moles. What does that mean? Well, as I look at this equation, it's just our basic construction of ammonia. I have gas, gas, gas. I have all gases, so I know that the pressure can be affected and cause a stress. Now, we said way back when that we could interpret this being 3 moles of hydrogen gas, 1 mole of nitrogen gas, 2 moles of ammonia gas. Now, if I add these together, my reactants have 4 moles. Okay? My products only have 2 moles. Right? Which do you think has greater pressure? Okay, I've got these in a container. Which has greater pressure? 4 moles or 2 moles? 4 moles. Okay? So, if I go from here, from this side to that side, I am decreasing the pressure. So, a pressure increases if I increase the pressure. With this particular reaction, it shifts to the side where we have a decrease. We just said that 4 moles going to 2 moles is a decrease in pressure. So if I increase the pressure, the higher number of moles, it's going to go away from the higher number of moles to the lower number. So if I increase the pressure, it will cause this equation to make more ammonia, because that's where the pressure decreases. It wants to even it out. What happens if I decrease the pressure? If I decrease the pressure, it's going to go to the side that has more moles, because it's going to increase the pressure of the reaction. Okay? Now, so here's the exact paper that I just gave to you, and it's dealing with ammonia. All right? So, if I'm looking at this, and I'm thinking that right here is my teeter-totter. Well, I'm not going to be able to write on that. Dang it, I'll have to change that. But right there's my teeter-totter, my reversible reaction bit. So as I'm looking at this, I'm going to ask myself a bunch of different things, and they're all included there. For instance, it says that the forward reaction above is endothermic. Okay? So where is heat going to be? If it is endothermic, where will heat be? Which side, products or reactants? It'll be on the reactant side. Okay? So heat is on the reactant side up there. The system is at equilibrium. Which way will it shift? NH3 is added. Okay? NH3 is added. How is that going to shift my teeter-totter? How's it going to affect my teeter-totter? Huh? If I've got a teeter-totter here, here's my reactants, here's my products, okay? I add ammonia. Ammonia is what? A reactant, correct? So it's going to do this on my teeter-totter. So which way is that going to shift? To the forward reaction or the reverse reaction? Okay? Maybe we ought to explain that. The forward reaction is going that way. The reverse reaction is going that way. So this one right here, okay? Here I go, right? I add more ammonia, correct? So it causes this way to go down. How am I going to even my teeter-totter? By going which way? That way. Which way is that? That is the forward. That is the forward. So if I add more NH4, I'm going to shift that to the forward. The volume of the container is increased. Now, when I'm increasing the volume, think about in terms of pressure. What happens? If I increase volume, what happens with pressure? It decreases, right? So basically what that's saying is I'm decreasing the pressure. So I have to look at the number of moles. Do I have all gases? Yes. Okay, got to check that first. I have all gases. Now look at the number of moles. I've got 4 moles on the product side. I've got 2 moles on the reactant. Does everybody understand where I get that? Now, if I decrease pressure, it's going to move to the side with the greater amount of moles because that increases pressure. So what side has the greater amount of moles? The product side. So is this going to shift this to the forward or the reverse? It's going to go to the more moles. So that would be the, going which way? That way, the forward. Now, the third one there is I add N2. Where's N2 at? Product side, right? So how's it going to affect my teeter-totter? Product side's going to go down, so it's going to shift towards the reverse reaction. Okay? Now I'm up here. I've got my products, I've got my reactants. They're balanced. Okay? I take out hydrogen. I remove it. Where's hydrogen at? Products. So if I remove hydrogen, my teeter-totter is going to go up, right? Because I took that out of there. So how will the reaction adjust? By going what way to relieve the stress? The forward. Now, where did we say that the heat was at? Where did we say temperature would affect? Okay, we said this was endothermic, right? So where is heat? On the product or the reactant side? Reactant side. So here I got my teeter-totter again. My heat's over here. I increase heat. What happens? Goes here, right? So how's it adjust? Forward reaction. Okay. Now, N2 is removed. Think about that. Picture that. Look where you got N2 at. N2 is removed. What's going to happen? What way will it adjust? It'll go to the forward reaction. Now, this next one's a good one. Okay? This is an actual question that I think I took off of WebAssign. But this next one is a good one because everybody looks at it and says, he is added at constant volume. That's not he, it is helium. Okay? Now, what's going to happen if helium is added at a constant volume? Helium has nothing to do with this, does it? Is helium anywhere to be found? If we throw helium in there, what's going to happen? It's not going to affect equilibrium at all. So there will be no shift. Nothing will happen. No shift. Okay? I guess if you could make a case to say, well, if you add helium, couldn't it make it more pressure in there? I guess you could maybe make a case of that. All right? Now, the final one is that ammonia is removed. If I take away ammonia, what happens? If I take away ammonia, how does the reaction shift? It goes towards the reverse. So it's going back to create more ammonia because I just took that ammonia away. All right, I just took that ammonia away, so it's going to create more.